good afternoon. Yes. In this video, we are going to see about the 8085 microprocessor. Okay. So how we are going to see this 8085 microprocessor using the 5 stages of design thinking. You know what is design thinking? What is the 5 stages of design thinking? What is 5 stages of design thinking? Empathy, define, ideate, prototype, and testing. Right. So I'm going to explain this microprocessor 8085 in 5 stages. Okay. First of all, empathy. So in 20 years before, right? In 20 years before, how we deposit the money? How we deposit the money? So we are going directly to the bank and we have to stand in the queue and we have to deposit, right? And if we want to fill up the challans and all, and we have to deposit, right? Now how we are depositing the money? ATM machine is to take the money. We have deposit machine. We have deposit machine. We will go directly and we will insert the money and we can deposit the money, right? That is called empathy. This empathy is based on microprocessor. If we don't have the microprocessor, we will not get the ATM. Okay, likewise. So in 20 years before, we are washing with the washing stone, right? And we have to rinse it and we have to dry it. Now what we have it now, the appliances. Washing machine. In between, first of all, we have a washing machine, washing stone, and in between we have a semi-automatic. What is semi-automatic washing machine? What the machine will do? What does the semi-automatic machine will do? What is the difference between semi-automatic and automatic? In semi-automatic, that machine only washes the cloth. It does not rinse it. Right, and it will dry it, but it will not rinse it, right? But in our higher technology, we have a full automatic. That is, if we put the cloth and we put some timer and we put some powder and all, and it will take some time to clean the cloth, right? So this technology is behind the microprocessor. If we don't have the microprocessor, we will not get the washing machine. Same thing, the microwave oven and the AC, all the automized equipments are based on this microprocessor. Right, now you understand what is empathy, because the empathy is nothing but I have to get what is the problem behind the people and I have to develop the technology. That is called the ATM machine and then washing machine and the AC and all. And have you know about vending machine? Vending machine. What are the things we have vending machines? We have a newspaper, chocolate, and then biscuits. Juices and all. In the mall and all we will see, right there. That's all. So vending machine for the newspaper, we don't want to go for the store and all. We can simply insert the coin. You can take the paper. So that is a vending machine. That vending machine is basically from the V.Pavithra. Even our digital watch, or whatever we are using digital watch, right? In the medical also, we are using this microprocessor. Why we need of this microprocessor is nothing but central control unit. So it will process the data, right? It will process the data. Simply we can say if you press the button, it will automatically washing the cloth and then it rinsing and then it is drying. So the processing happened in the washing machine. So that is the central control unit. Then performs ALU, not only in appliances and all, and it can be used in a arithmetic or logical operation. You know what is arithmetic: addition, subtraction, multiplication. And logic is nothing but and or get. Next one, the processing data quickly. For example, if we are taking a sensor, means from taking the sensor, we are taking the data from the sensor. There we need a processing. So there processing data quickly, right? Then control peripheral, flexibility and compact and efficient. Already in the class I have shown you the microprocessor, how small it is. So the small IC, that is a microprocessor. So that's why it has a definition of microprocessor. It's a single integrated circuit that performs the ALU, input, output and control operations. Right? And so these are some of the applications what I have discussed now. That is one of the computer, next is home appliances, washing machine, whatever the things is, and then consumer electronics and medical equipments. Medical equipments, we no need to go for the doctor and all. If we have the smartphone, what will happen? We can simply check our pressure, right? But when the condition of seeing the accuracy, I don't know whether how accuracy, but we can check it our pressure in home itself, right? We don't want to go for the medical shop or we don't want to go developed by Intel. The main components of the 8085 microprocessor is arithmetic and logic unit, registers, program counters, stack pointers, timing and control unit, address bus and data bus. Arithmetic and logic units, it performs all operation or all arithmetic operation, addition, subtraction, and logic operation and not, etc. Registers, you have stores to maintain memory location to store data temporarily. The main registers are D, C, D, E, H and D registers. Timing and control unit, it controls overall operation in the microprocessor. Stack pointer, it points the stack on top which stores temporary data and return the data. Program counters, it keeps the counters which return the data and program counters. Instruction set and decoders. Instruction set holds the instruction to be executed. Decoders what to be understand the operations to be executed.
Hi, I'm Varun. I'm currently taking computer science and engineering from SNS College of Technology. I will explain about the IDE. IDE is nothing but we must actually use a base based on the empathy. To improve the 8085 microcontroller, we take the ideas in first step. First, the efficient data flow. For insert the data into the microcontroller, the efficient data flow is must. That's why we can use two buses, address bus and data bus. Address bus consists of a 16-bit and the data bus consists of a 8-bit. Next, to simplify instruction execution. For executing the instruction, we must need a control unit because it handles the timings and instruction decoding. Next, to improve the process, we improve arithmetic and logic unit. For comparison and arithmetic operation, we use arithmetic logic unit ALU. That performs addition, subtraction, and not and some operations. And for performing data storage, we can use fifth register, general purpose registers like B, C, D, E, and H and L. It acts as a temporary storage, so we don't need to receive the external data again and again. Thank you.
Hi, I am Rishikesh of CSE in SNS College of Engineering. My topic is prototype. First, we need to complete the prototype. We need some components. The components are this. First, we need 8085 IC. It will be act as a CPU. Then 8255. It will handle the input and output. 2764. It stores the program. 6264. It stores the data temporarily. 74LS 373 adds the separate address and data line. LED and switches used for testing input and output functions. 6 MHz crystal oscillator provides clock signals. 5V power supply. Power supply to entire circuit. PCB. It was the platform for assembling components. Thank you.
Hi, I am Sandeep, second year BSc. Now I am going to tell about testing. First of all, anybody know about 8085?
Anyone knows?
There are particles in 8085 and it is used to control address, data and power.
So what is the power supply given to the IC? What is the power supply? Maximum power supply we have to give for the IC? 5 voltage. So he's trying to say that, but right? That's what you are saying now. Yeah. How many pins are there? 40 pins. And what are the special characteristics of that 8085? 8085. things about microprocessor in the class, no?
It's a 16-bit microprocessor.
Yeah, very good, very good. Please clap the hand. Please. 16-bit microprocessor, right? So this is first of all it was designed with 8 bits. Then it comes for 16 bits. Then anyone? Special characteristics of features of 8085. 8085. Yeah. Anyone? So we like to conclude here, right? So what we have discussed in this class, 8085 microprocessor. So she have said she have discussed a lot of architecture, right? And what are they? Registers. First of all, accumulators, right? Accumulators denoted as A. And the next one is registers. Then program counter. Then stack pointer. Addressing mode, address and bus, right? Then instructions and decoding, then control unit, right? These are all the definition for a microprocessor. So I have discussed why we need of this microprocessor. She have discussed the what are the things are in the architecture of 8085, and he have explained the idea how to implement the 8085 with how to insert the instructions and what are the operations are performed. And then we have discussed the prototype. Prototype is nothing but what are we are getting in our hand, that is a prototype. For example, we have a project, right, that is a prototype. And then we are working with that is called testing. So the testing only, you have asked if you want to design a processor, you have to use a 40-pin microprocessor. Okay, this hardware is not, we can't only use with this hardware, we have to use the software also. So if we want to implement the project, we have to use the software also. I hope you can understand this topic, right? Yes, thank you.